So here in this video guys, we're gonna examine what's gonna happen to a water tank or to a tank that is full of water in it, and compare it to what's gonna happen to a solid if we put it on the surface or something flat surface. So if you imagine a solid, if you put that on a surface, it will only exert downward forces. But if you compare it with a fluid, or it could be liquid or gas, that liquid will always find way to exit somewhere, and thus it is exerting a force all over the place. So if you imagine a water tank that's filled with water, of course that's water tank. All of these water molecules here is exerting forces all over the place. Alright? So here in the surface, if you imagine a molecule here this big, above it there's only less force or pressure that's pushing it. But if you go deeper beneath this molecule here, will experience more pressure due to its depth. So that's more intuitive, no, that if you go deeper to a body of water, you're gonna experience more pressure. If you've been to swimming in the sea, you go very deep, your ears will experience more like burst in your ears, because that's because of the weight of the water pushing you all over the place, all over you. Alright, so now how can we relate this to Bernoulli's equation? If you imagine a tank guys, and you make a hole right over here, of course what's gonna happen? The water will spill out, will leak, and will find an exit. So with this one, if you ask yourselves, what's the reason of that motion? What's the reason of that fluid moving? So the reason for that is the difference in pressure. So if you go back and you didn't make a hole in that, the exterior or the surface of the tank, the pressure of that is gonna be equal to the force of the water that wants to exit, diba? It's more like this is the hole right here. This water that wants to exit is equal to the force that's the surface of the tank is exerting, diba? So when you remove this cover, then there's no equilibrium that's happening here. No longer balanced. The forces are no longer balanced, so the water is gonna spill. Alright, so we can say here that there is a pressure difference. In this first scenario, wherein there's no hole or a tank, the pressure is equal to each other, right? So there is no motion. So think about that. Whenever there is a moving fluid, of course there should be a pressure difference, right? But in here, we can observe that the pressure are equal because the fluid isn't moving either, and the forces are equal due to the surface. But when the cover is removed, the fluid finds its way out, diba? Ano ni siya? It results from unbalanced forces and what you call net force and a pressure difference. Alright, so that's the pressure that this term here in the Bernoulli's equation is referring to. Alright, so now if we have a simple example here of a tank and a pipe going out, something like that, and we assume this is a 5-meter long pipe here, and this is the water level of the tank, and we assume our reference point to be here on this line right here, and this we say as 8 meters, assuming that's 8 meters, and we want to calculate what's the velocity or the discharge ba? What's the discharge? We know discharge is just the amount of, or the volume of fluid going through a surface or through a cross-sectional area per unit time. So now we want to know that, just basically need to apply the Bernoulli's equation. So that is pressure at the first point. So of course we're gonna assume points. So we're gonna choose a point, maybe here at the water surface as point 1, and here at the discharge point as 0.2. Alright, so by then applying Bernoulli's equation on these points and assuming no head loss first to make our calculation simpler, we're gonna have P1 over rho g, the formula we had from the previous video, plus the elevation plus the b squared over 2g terms, or the kinetic energy head, is equal to pressure at the second point we want to analyze, z2, and then the b squared over 2g term. Alright, if we analyze the first point here, is there a pressure acting to it? When we assume this is open to surface, there's no cover on top. So in order for a fluid to move based on what we analyzed in the previous video, we need pressure difference. But then here we can see that the first point is open to the atmosphere. If we are too technical on our solution, we can say that this has a pressure due to atmosphere, right? Because it's open to surface. And so does here in the discharge point. It has also a pressure due to atmospheric pressure. So if you think about it, is there a pressure difference between them? I can say the pressure at point 1 is 0 because it's open to the atmosphere. So what's the only pressure the aira ang cause for the motion? What's the pressure difference that's making the fluid move from point 1 to point 2, or from discharging it from the reservoir or from the tank? I can say that the only reason that there is pressure difference, or the only reason for the motion of the fluid for it to flow, is the potential energy. That's the only thing. Alright, the pressure due to the work done with the pressure is like right here. There is no pressure. There's no pressure due to that, but rather the only pressure acting to it is the potential energy, the elevation of the fluid. The weight of the fluid is what's making it flow from point 1 to point 2. There's no other pressure pushing that fluid to move right here. Right, so the pressure difference due to the at least with this term is nothing. So if this is nothing, this pressure 2 is also be 0. Now what's the elevation if this point right here is our datum? So the elevation of point 1 is gonna be 8 meters. Now what about the velocity? We say that this the fluid is moving, right? So there must be velocity. But if you think about point 1 right here, this point here, and compare it to the motion of the fluid, the movement of fluid here at point 2, we can say that the velocity at point 1 is negligible. Why? Because it's far more slower. The movement, the decrease in height of the fluid on the tank, of the water in the tank, if you think about it, is much slower compared to the velocity of the fluid going out here at point 2 on the pipe. Diba? As the water drained out from the tank, the height of the water inside the tank is just very slow. The movement, the decrease in height is just very slow compared to here at point 2. So we can assume that the velocity v1 on this point is 0. So if v1 is 0, then 0 squared is 0, and 0 divided by 2g is 0. Now for our point 2, what's our elevation there? Since this is our datum, then our elevation there is going to be 0. And of course, this is what we're looking for. The b squared over 2g, or the velocity of the water discharging from this point, or from the tank. So if we solve for b squared, or if we solve for velocity here, we know the acceleration of due to gravity, that's the only term. Then we can now solve for velocity 2 as equal to square root of 2 times 9.81 times 8, or that's going to be 12.5 meters per second. So that's the velocity of the water going out here at point 2. Right? If we calculate how much volume is going out per second, we're gonna have to just multiply this velocity by the diameter of this pipe. Right? So if we assume that pipe is about 20 centimeters in diameter, or that's going to be 0.02 meters. Q is just equal to AB. So 0.02 meters, that's the diameter. So the area would be that square times pi over 4 times this velocity here. Then Q is gonna be equal to, Q is going to be 0.0039 meter cube per second, or that's going to be 3.9 liters per second. So that's the amount of volume going out here when the water is flowing at a velocity of 12.5 meter per second. So that's it for this example, guys, and I hope you learned something from Bernoulli's equation here. If you have questions, feel free to comment down below. Hit the like and subscribe button below. Thanks for watching. Peace out.